Hello, everyone. Welcome to track 3 for the last talk of the day. Quick reminder that there's an after party at the Level 1 Arcade on Main Street, walkable distance from here. If you want to, the con opens tomorrow at 8 with the first talk starting at 9. And with that, I'll turn it over to Yelena and Trev Dog Millionaire to talk about navigating blind SSRF, attacking and defending critical systems.
Thank you so much for coming. I'm Yelena. I work for a financial company. I'm not here on their behalf, but I do help run their public bug bounty program, and I also work under the Red Team umbrella.
Hi, I'm Trevor Costanzi. I am a staff platform security engineer. When we wrote this talk on a Sunday, it was 2 days after I was laid off and I was unemployed. It turned out on that Tuesday, I got a new job offer. So I'm not unemployed. God bless America for that. I do a lot of DevSecOps and kind of like other fun buzzwords, and I'm going to talk a little bit about that in this presentation. Hopefully I won't talk too far above your heads today, but feel free to come to me afterwards if you have any questions, or you can reach me on LinkedIn or whatever if I talk too much. As you can tell, we're two people with silly hats. Shout out to the silly hats in the back. Basically, kind of the idea is here, she's going to be giving an offensive perspective. That's why she's got the fun pirate hat. I have the British Navy hat, so I'm giving the defensive perspective. Hopefully that didn't go too far over everyone's head. There is a purpose to the silly hats, I promise.
All right. Did anyone come to my talk last year on SSRFs? Sweet. Yeah, I got a lot of blind SSRF questions and then WAF questions, and I'll be answering them today. If you have any questions about SSRFs that I do not touch on, I gave an hour-long talk on it last year, so I'll try to stay intermediary. But for review, what is an SSRF? You're tricking a server into doing something on your behalf. So it's a good way to get malicious files onto a network or access internal use only resources. And like I said, we're focusing on blind SSRFs. The difference here is with standard, you're fetching data, and with blind, you have to get that data indirectly. And I'll go into detail on that in a second, but first I'll go over the diagram of how an SSRF looks. You can see here, attacker sends a packet A. A public server consumes that packet, probably changes some headers, some information, forwards it on to an internal server. That internal server responds, it processes your request, responds, gives it to the public server, and you're supposed to see that response. RIP Kevin Mitnick. If you send off, the gist of it is when you're interacting with a web app, you're interacting with a website. Okay, so here we have Facebook. That could be a number of things, putting something in the URL, signing in, filling out a form, etc. But somewhere in that interaction, you're going to add your SSRF payload. When we deal with public servers, that's your client-side server. If it needs any sensitive data, it will make that request out to your internal servers. The gist here is an SSRF, that public server is going to request something for you, send it to the internal server, and that internal server responds when it shouldn't. It's lacking some form of input validation, something's going on with it, but it responds. And with a blind SSRF, you don't get to see it. So how do you know when you have a blind SSRF, and how do you get information with a blind SSRF? So with any SSRF, you're likely looking at a response code of a 200 or a 300. That's not always the case, but that's common. And there's two main ways to get information back with a blind SSRF. That's your out of bound and your errors. That can look like timing differences, differences on the web app itself, error responses, or when you're doing out of bound, which is what I wanted to focus on today, you're using a server that you control to indirectly get back information. Now, if you use Burp Suite as much as I do, Burp Suite has a tab called Collaborator that will spin up an instance called Ostify, and you'll use that to get information back. So you don't have to go out and make your own custom server. You can just use the Burp Suite built-in function for Collaborator. Oh, uh-oh. Give it a second. It's a little loose. All right, so I've seen a couple of blind SSRFs. This is a highly redacted example of one that's fairly simple. Here we have a GET request to, and I've put a random route there, some route, some web page, and it goes out to like an ASPX. And we have a vulnerable query parameter here and then a payload. So I'll zoom in. We're attacking example.com as the host, but what we want to zoom in here is our vulnerable query parameter and then our payload. So when we send out that request, I think that was in there. All right, here's an example of one vulnerable query parameter that I will be using. I will give many query parameters that you can try, but this one's meetURL. It's for conference links, things of that nature. And the nice thing about meetURL is it consumes URLs. So when we're dealing with Ostify, it's a URL that we'll be injecting as the payload. So you want a query parameter that would, by default, consume a URL. So how do we know that we have a vulnerable query parameter? I'll start with the bottom example and work my way up, but the easiest way is some sort of automation. You can go on Burp Suite and get the Burp extension, param miner, and it will assist you. But we wouldn't be red teamers if we're not manually testing our vulnerable parameters. So you also want to be looking at the behavior of each parameter and trying some manual injections. You'll be looking at, does that query parameter go and fetch me data? Does it validate URLs? Can I get it to validate a URL that it wasn't intended to validate? Can I inject additional payload after that URL? Is it scrubbed? Here's an example of a payload. This is the most simple payload you'll use. You go and get your instance from Ostify. So where I put example would be a bunch of strings and random digits because it's an individual instance, but hopefully you get the gist. But of course we have to focus on bypassing the WAF. So when you get your instance of Ostify, you have to go a step further. There's a lot you can do to bypass the WAF. These are 4 of the most common things I see on a regular basis using base 64 encoding, URL encoding, and here I've only URL encoded the special characters. Double URL encoding is a popular one. And my favorite is using IP over DNS. Sometimes when a WAF is misconfigured, you can use IP instead of the DNS, the domain name, and you will be able to get more payloads to bypass the WAF. This is what your Burp Collaborator looks like. I've edited it a little bit, so it's a little bit bigger, but I wish I could get away from this mic so I can point at things. But okay, so at the very end where it says source IP address, that's going to be your most important thing to verify. I commonly see people reporting WAF IP addresses. You want an internal IP address to your victim. So if you're able to look up on who owns that IP, it's probably a safe bet you have a valid out-of-band blind SSRF. The most interesting type is HTTP. You see an HTTP request to your Ostify instance, and then you have that source IP. But we wouldn't be red teamers if we did not further the finding. So for bug bounty, if you had this, you have enough for a payment. But if you want a good payment, one of those heavy hitters, you want to further the finding. Okay, so we have our basic payload here, and that's your Ostify instance. Now add in additional things, see if you can get by. Try a basic ping. Can you add on information to your payload? My favorite is line 8. Can you get to Etsy password? Now, it's a misconception, or I think a common misconception, that red teamers break things and walk away. And though I do love doing that, it is a huge part of our jobs to know exactly why something was vulnerable and know how to fix it. And so we collaborate heavily with incident response teams, the WAF team, our developers on coming up with a fix. The most common fixes, and there are some exceptions, will be your input validation. And the best practice is whitelisting. You can also use a regular expression for less code, depending on the parameter that you're trying to fix or whatever's vulnerable. Also, patch your stuff.
Thank you, Yelena. Now you've learned a bunch of the fun offensive security techniques. You're probably going to be bored now because I'm talking about the boring blue team defensive stuff. So, like, if you're a security engineer at a company, you know, how do you defend yourself against blind SSRFs? Well, blind SSRFs from like a blue team perspective, they're not really any different than 99% of every other, you know, web application security vulnerability. They almost all have some form of lack of input validation as the root cause to why they're occurring. And that's because you're either not, you know, validating query parameters, you're not validating, you know, any headers you're accepting, cookies maybe, you know, cross-site scripting is even very much the same way, where you're not, you know, properly validating an input that causes, you know, that type of vulnerability. So from our perspective, there isn't really that much difference, but if you're looking for a main one, blind SSRFs are typically lower severity findings because they're harder to exploit due to the kind of the nature that you have to do more work to exfiltrate data. So what are some defensive strategies if you're a security engineer right now and you're at a company and you're like, how do I deal with this problem? Well, let's talk about a little bit of a buzzword first, DevSecOps. You know, I give a lot of talks. I call them all DevSecOps and other buzzwords. What does a robust DevSecOps process looks like? We'll talk a little bit about that later, but think about things like doing static application security testing so you can detect, you know, maybe where we're already missing lack of input validation. Software composition analysis, where we're checking for, you know, our third-party dependencies. Are they vulnerable? Things like that. You know, another great strategy, you know, if you're not already using infrastructure as code, you know, I understand, but you should be getting to that point where your infrastructure is built using, you know, a tool called like Terraform or Pulumi or CloudFormation or CDK. Because what we can do with that is we can declare infrastructure. We know what our infrastructure is going to look like after it's deployed. We don't need to deploy it to scan it for vulnerabilities. So we already have that information before it's out there. You know, the vulnerability is so much cheaper to resolve if it hasn't existed yet. You know, you're not introducing risk by the time you've already fixed it. And then we can make abstractions where, you know, we as security engineers can you know, have input into the abstractions for our infrastructure. That way we can automatically have secure default states for when our developers are going to build things. Other really important things, have a defense in-depth strategy. Don't rely on any one control. A lot of companies, especially large financial institutions, love to rely really heavily on things like WAF. You know, I've definitely worked a lot of places where I go, hey, there's a vulnerability in this. And they go, oh, the WAF is there, you're fine. No, you're donezo if that's the case. Kubernetes has a lot of great like automagic things you can implement, like Istio, that does things like service mesh and software-defined networking to prevent, you know, access to unintended areas. Like in an SSRF, you know, if this thing isn't supposed to access that resource, it just won't be able to. API gateways are really cool. Make sure you're segmenting your network to prevent like blast radius. You know, don't rely on any one of these controls. Make sure you're combining them to have the most effective, you know, security program. Input validation, input validation, input validation. If you're reviewing code, you're doing any code reviews, or you're just, you know, writing something yourself, input validation is so important. Well, again, almost every web application security problem has some amount of lack of input validation involved. And, you know, this should go without saying. We're a room full of security professionals. Patch your shit. Vulnerability management, I understand, is not easy, but, you know, how many, you know, huge data breaches have happened? How many times have you lost your social security number to the internet because some dude had a really vulnerable Apache web server that they knew about for like 10 years and just didn't do anything about? Not a great time. You know, keep up with your program. You know, another thing, you know, it's not just servers, you know, patch your third-party dependencies. A lot of your code, probably as much as 80% of your code, is actually somebody else's code because you're using third-party libraries to do a lot of the work for you, so you don't have to reinvent the wheel so much. So, you know, I'm looking to detect, you know, this type of issue. What might that look like in my network? One, you should look for suspicious network traffic. Now, what does suspicious network traffic even look like? Well, first, you should be baselining your applications. A lot of SIEMs these days have AI in them. They'll do a little bit of that baselining for you. And so you'll know when to look for like suspicious things that are out of the ordinary. But like, what is something your app should like never responds to? Why is my app going to, you know, example.china? Probably shouldn't do that. Your app shouldn't be sending data to China most of the time. You're not TikTok. Weird HTTP callbacks. So like in the example where we have like an HTTP and then we have a vulnerable URL parameter and somebody's trying to access 169.254.169.254. If you're not familiar with what that is the internal metadata service endpoint for most cloud providers. That is where, you know, if you're on like an EC2 instance in Amazon, which is a virtual machine, or in GCP or Azure, that is where you can reach out to that address and get credentials from the instance. That's really useful if you're building an application, but it's also really useful if you're attacking an application and you get access to a system and then you have access to that system's credentials. Most of the time, your application shouldn't be reaching out to that address. It's probably atypical. If you see logs for that, that's a problem. If you see something like get access ID or get, you know, what would be the, you know, the regex for what a token looks like an IAM token in Amazon. Probably shouldn't be a get request for that in your application. Something's going wrong, right? What a lot of people don't understand as well is like, what if you have a blocked request, but you also have DNS resolution? Well, a lot of people don't realize that you might block a request, but your server's still going to reach back and try to like resolve the DNS of that host that reached out to you. So you can find a lot of weird stuff there as well. So if you're getting a lot of blocked requests, but still resolving DNS, maybe something bad's going on. Sometimes a way to exfiltrate data, like in blind SSRFs, you know, you're not seeing the payload. They'll send their request from, you know, a subdomain of a domain they control, and they'll use that to exfiltrate data. Like they'll have the session token be a subdomain of a domain they control. That way they get that DNS request back to their domain. They know that's your token all of a sudden. That's like a common exfiltration method. What are some common targets? Like I said earlier, that HTTP metadata service, most of the SSRFs and blind or otherwise that I've seen in cloud environments, almost every single one of them has tried to reach this address. It's a very easy way to detect it. It's like running Who Am I in Linux or on Windows. You're like, nobody should be doing that. Please stop. You know, it's like it's an immediate red flag. Local and remote file stores, like Yelena said earlier, Etsy password. If you know anything about Linux, you know, it's pretty odd that something would be reaching that, especially like in a GET request. It'd be very odd that somebody hit that. You know, any of your databases, you know, if you're, you know, Navy Captain Trevor and you're trying to run, you know, your security program, you should know where your like golden tickets are, where's your booty stored, so that you know what to protect. If you rely heavily on WAFs, one, you shouldn't rely super heavily on WAFs. They're not that great. You know, what are some things you should do? One, you should have multiple layers of URL decoding. Like Yelena said earlier, one is not enough. A lot of people will try two, sometimes more. Block non-HTTP schemes if you're not using them. A lot of people forget to do this. Validate your resolved IP addresses after DNS resolution so that they're the same that they're supposed to be. That's a problem. Make sure you're handling IP formats correctly. A lot of people will like shove in IPv6 as a way to get around WAFs, because effectively a lot of what people do with WAFs, especially people who don't know quite as much about how to successfully configure them, is that they will attach them to like a domain name and then forget that you need to attach it also to people who reach out to the IP address and the IPv6 address, et cetera, et cetera. Make sure you have rate limiting in place. A lot of the internet is just like malicious bots just smashing against every website on the planet. So if you have rate limiting in place, you mitigate that risk a lot. And if you have like Yelena said earlier, a lot of people are going to use like a param mining tool that's going to automate like testing out a lot of params. If you rate limit that, you slow down that process a lot. It's easier to detect and block that person. Allow lists instead of block lists, obviously. Why allow lists are so important. You're not going to remember everything in the world that you need to block. There's just too many things. So if you instead think from like, what do I allow, and work from there, you have less things to worry about in your application. Now, you might not be able to see this, but our code will be online. We'll have a link to it at the end so that you can get it. But like, a lot of security engineers aren't looking at code every day, so you might not be familiar with what vulnerable code actually looks like. In this case, we have a basic Python Flask app. It's like the most basic web server you could possibly have, so trying to dumb this down as much as I can. We have a route like fetch avatar, like on any website where you have an avatar, there's probably some type of fetch avatar function. In this case, we take an argument, like a URL parameter, and that parameter fetches, wherever your avatar would be stored. Well, as you can see here, we're actually just taking that and then getting it. There's no input validation there. That's bad. I'm not going to show you what that input validation might look like. That way you don't like take this presentation and then implement it at your job and then go, Trevor, what the hell? I don't want to be responsible for that. Don't put those demons on me. But as you can see here, basically, it's just going to try that response immediately. And then it's going to, if it's successful, it's just going to return successful 200. It's not going to return any other information. That's how you know it's a blind SSRF rather than a regular SSRF. Where a regular SSRF, there would be more data in there, or else it's going to send 400. So if that 200 happens and you throw in your thing, okay, you've got probably a blind SSRF. Now you have to work on how do I further that vulnerability. Now, if you're on the blue team and you're like, Trevor, you're talking about blue team stuff. Now, why are you showing me this burp suite thing? Well, you should if you're doing product security or you're in an org where you're helping build secure applications, you should be relatively familiar with this. You should be able to do cursory tests of your own applications you're working on. That way you can validate findings that come in. Like if you're working, any type of bug bounty, or just so that you can do cursory tests on your own, in your free time. It's something I did a lot at my last job, so it is really helpful. In this case, this is a very basic example of an out-of-band, blind SSRF, where you see on the big side at the bottom, there's we take in a referrer header, and guess what? We're not validating that input. I can shove in whatever I want there. In this case, I'm shoving in my OASTify, address from Burp Collaborator, and I'm getting, a response 200. I know because I've gotten a response 200 that it's likely vulnerable to blind SSRF. We can further our finding from there, but as a blue team member, I know that there's a problem. I'm going to go look at the code and see what the problem is, and we can fix it. So what are some ways we can mitigate and prevent this, right away? So I'm going to talk a little bit more in depth about all these things, right after this slide. But like I said earlier, secure default infrastructure abstractions. Use something like Terraform, Pulumi, CloudFormation if you're, or CDK if you're an AWS shop. They all have kind of their own if you're in a different cloud. So, whatever works for you guys is great. Make sure you are doing security testing as part of your end-to-end tests in your SDLC. You should be doing CI/CD at your organization. If you're not, you're wrong. I understand why you're wrong. It's hard to get there sometimes, especially if you're living in kind of an old school world. But try to get your organization there. Do tests inside your pipeline. If you're a blue team member, start writing your own end-to-end tests. That way you're automatically testing for potential SSRFs, blind or otherwise. Make sure you have strong relationships with your application teams. Security has a habit of being like a department of no and just saying no to everything. I can see all your faces. You've seen it in the past. I see my wife's face over there. Love you, babe. So we've all seen it. It's not a good look for the organization if you're just like not building relationships that are positive with the teams. You know, these are your coworkers. These are people you work with. If you don't build strong, positive relationships, if you don't build trust with these teams, you don't have security. Just flat out. You just don't. If they don't want to work with you, they will not bring things to you. When you need things fixed and you find something, they won't respond to your email. They won't respond to your Slack. You'll Slack them. You'll get 3 days later, you'll just get a question mark. It doesn't work. If you have no trust, you have no security in your organization. So build positive relationships. Terraform modules are amazing. What does Terraform module look like? I'm not going to explain exactly how Terraform works today. Feel free to come with me afterwards. I can talk about this. Basically, Terraform is a declarative language. We say, I want this resource in AWS or Azure or wherever, and this is the configuration I want for it. In this case, I'm using the most basic building block of AWS infrastructure, an EC2 instance. An EC2 instance is just a virtual machine. Now, virtual machines have a ton of different configurations. Now, if you're thinking about secure abstractions at your organization, don't think about the whole thing. Think just about the configurations we as security professionals care about. We care about, making sure we're using the most secure version of the metadata service for that cloud. In AWS, the default metadata service defaults to version 1. That is the same metadata service that got Capital One hacked in 2019. I didn't say that. You don't even know when you're building these things half the time that you have to, if you're an app developer, you're not even a security person, you don't even know half these configurations exist. You don't have to specify metadata options in Terraform. I'm a security engineer. I can specify them here. They never have to think about it again. What other thing do we care about? What security group are they using? Security group is just a firewall in the cloud. So I care about that. So I can specify that here. I can specify things like, I want this thing to be encrypted, something that most app developers don't care about, but we as security engineers care a lot about. So when I'm getting an audit from SOC 2, accountant security guy, and he goes, how do you make sure all your services are encrypted? I point that right there, and they love it. They don't know what I'm saying, but I can point at it, and it passes an audit finding. So I can set all of these things as a default, and then if an app developer needs to have some configurations that aren't, that are specific to him, then or her, they can just specify it here. And then you can see here, I don't have to specify anything about the root block device. I don't have to specify that it's encrypted. I don't have to specify the metadata service. So my app dev no longer has to worry about those important security things. So that's a really awesome way. This is just a basic example. You can get really extreme with this. At a lot of orgs, I've gone ahead and just created their entire infrastructure stack that they would ever create. If you're creating APIs and microservices, it's the same infrastructure every time. So I've built all of that out, and all they have to do is call one thing and say, I want a new API, and then this is what it's called. Here's a couple of configurations. Bam, all their infrastructure is secure by default on the cloud side. No misconfigurations. I can scan it in a CI/CD pipeline before it's ever created. I know the whole time that we're deploying good shit. Now, what if you're an organization that uses Kubernetes and you want fancy Kubernetes magic? I'm looking at all of you and you're like, what the hell is Kubernetes? I don't blame you. Kubernetes is basically a system for managing containers. I don't want to go too in depth on it. Again, come talk to me afterwards if you want to. Kubernetes has this awesome thing that you can implement called Istio. Now, what's Istio? Again, most of you probably don't know. But Istio is basically a software-defined networking tool for Kubernetes clusters. What it gives us is basically a service mesh where every single authentication between anything in our cluster of containers and services is authenticated using mutual TLS. Therefore, I, by default, make sure every inbound and outbound connection only goes exactly where I want it to. So if a system shouldn't be reaching out to weird things internally, guess what? It can't. And that's a really useful way, in a Kubernetes environment to make sure that there's no guesswork there. I've taken that out of the hands of app devs who, they just want to build features fast because that's their incentive at work, is to build features and deploy fast. I've removed that thought from their head. It's just by default. Another great thing in Istio is that not only do I have to say that this server can only go to example.com, but I also have to say it can only go to subdomain.example.com. So I can even make sure it doesn't go to subdomains or only to subdomains that I want. And that's super useful. I've seen that, stop issues in their track 1,000 times. What does an actual DevSecOps process look like? A lot of security engineers have not worked in an app development environment. DevSecOps starts even before we start writing code. It starts in the planning phase. As a product security engineer, I involve myself very heavily in the planning phase of how we build products. So I'm going and I'm sitting in sprint planning. I'm helping, make sure that we include security features in our tools early on in that process. We're collaborating in Slack and in Jira. And then, as we write code, we deploy it to GitHub. And we commit it to GitHub, our version control system. And then once we commit it to our version control system, we create, a pull request, or we create a branch and we create a pull request. And then I create that request. It's going to kick off a bunch of CI/CD tests. And in that test, you might have things like linting, which is just making sure your code's the right style, basic stuff. But then I also have static application security testing, where I'm testing, I have a tool like semgrep or sneak, and I'm automatically scanning my code for common, patterns of things that are insecure. And then you can do everything from, like I said earlier, you can scan your infrastructure code. You can scan your Docker containers. You can run your containers, the applications on your container, and then you can run DAST against them, your dynamic application security testing. And you do all of that before you've deployed it into an environment where you're at risk. Now, what does that actually look like, in practice? I've talked to a lot of new engineers, and they're like, I don't really understand CI/CD. So if you look at the bottom part, and I understand this is a little small for you. Again, this presentation will be online. You can take a look at it, or you can reach out to me. I can show you more examples than this. CI/CD is basically just a collection of bash scripts, or you can write Python and then shove that in your bash script, but it's basically all just bash scripts. Here's 2 lines where I basically pull a Docker container, and then I run a Docker container that has a tool called Bandit. Bandit's just a static application security tool that's open source, and then automatically, that's all it takes, literally 2 lines, and I'm running static application security testing in my CI/CD pipeline. And I'm outputting it in a JSON format. Why do we do that? Because JSON's really great for doing more automation. For example, when I was working in the DoD, all of our tests outputted to JSON. We then collected all that JSON. We shoved it together in one giant spreadsheet, and then that spreadsheet would go to like a paper pusher in the military, who then had to look at all that, because in the military you have any really highly regulated environment, you might have like somebody who has to say, okay, this is fine to deploy. In that type of environment, it's like an ISSM in the military, and they have to give you the green light. That can take 8 months for most of the military to deploy even like a very small update to an application. But if you can automate that all into one big pipeline, and then you can deliver that person who's doing that ISSM job, and then be like, hey, here's all the scan findings you need per your orders and your regulations. Everything's right here. It's all green. All you got to do is press this green check mark. It'll deploy. And then, bam, you've taken an 8-month process down to less than an hour. And this is an actual thing I've done. It's not something that happens overnight by any means, but if you can save 8 months every deploy, that's a lot of time. It's worth the effort. And as you can see up here at the top, this is another thing. This is an example of like what another static application security testing tool might find in your findings. In this case, the example is using Sneak, which is another great tool that I've used really heavily. As you can see, it scanned our code. It goes, hey, I don't think you've sanitized these inputs. You're not doing proper input validation. This might be cross-site scripting. And this other line might be a SSRF. Wow. Now I can prevent that problem from ever getting into my environment. Identity and access management. Kind of a boring topic, not gonna lie. Almost nobody goes, hey, IAM, I'm super excited about that. Kind of sucks. No, well, my bad. But the crux of a lot of cloud breaches are that they get a set of credentials, and then that set of credentials has too much access, and they are able to then, get to like an S3 bucket that's full of a bunch of data, or a database that's full of a bunch of data, or any number of data stores that have just too much, or they're able to, privilege escalation or do anything. You want to make sure it's really important that you configure least privileged IAM roles in your organization. You can do this in Terraform. I did it really heavily in Terraform at all of my previous jobs. You can create a really nice web of service control policies that happen at an organization level, resource control policies that happen for like that specific resource. Like I never want anyone to be able to, set legal holds in S3 buckets because those are really bad. And then you can have individual IAM policies for different objects, resources, and users that you can then create this really secure web of policies that prevents people from doing any number of bad things. What are really common mistakes? If you're a security engineer, you've never looked at IAM code before. The really common things are people putting an asterisk in an IAM policy like S3:get star. The asterisk means I get everything that starts with S3 get star, which is a lot of things. It's not just object level things, like if you want S3 get object, which is just like, how do I download a file from a bucket, which is a common thing you need. But it also is like, can I get the bucket configuration and the IAM policy for this bucket? And so if you can see that and you shouldn't, then all of a sudden you can look for ways around the policy. You can also put legal holds on the bucket. Legal hold cannot be taken off of a bucket unless you have Amazon support do it, and even then they might not do it. Real bad thing to have. Don't let people do that. Again, combine these things, you get a really secure by default environment. Story time.
Oh, yeah. This is the most common question. Can you tell me fun stories about blind SSRFs in your environment? No, I cannot. I will say, as a red teamer, we do see SSRFs, but there are some vulnerabilities that are too critical. I've never not rated an SSRF as a critical. It hasn't happened yet, and we wouldn't sit on that for an op. That's not op material. That's something we want to fix because it's a risk to our clients. So where you want to get your fun stories are from blue teamers, because they're going to see actual attacks on the environment. If you're doing something like a bug bounty or proofing out as a red teamer that something's an issue, you would stop at the point where, hey, look what I can get. But when you're talking about somebody who's being malicious, that there's going to be far more stories and damage there. So, without further ado, some actual good stories from Trevor.
Yeah. Let's go. I know you're just so bored of me talking that I get to talk again. Woo! So let me tell you a story about an unnamed startup that I definitely worked at, that I will not name, and that this is definitely not a real file that was uploaded to an application. So what happened? So I worked at a company. Our company did AI and ML for like document automation. So we took documents as part of our process. There was an API that let them basically a URL parameter, in one of our APIs that they could change and redirect, give us an SSRF to a file that they controlled in a server they controlled. So they download a PDF, which to us wasn't necessarily suspicious because we process PDFs all the time. Well, but this wasn't a normal PDF. This PDF contains what's called PostScript. If you're not familiar with PostScript, I wouldn't blame you unless you're really familiar with PDFs. You wouldn't be. It is basically a scripting language entirely for PDFs. Who created a document that has its own scripting language? I don't know, but I hate them. PDFs are the devil. They can also run JavaScript. Why? I don't know. So you can run Doom in a PDF, I guess. But basically, as you can see, or maybe not see, at the bottom of this script contains a Ruby command, and that Ruby command starts a reverse shell, and that's bad. And this is how I learned that you can get root access to somebody's AWS Lambda, and then you can dump the credentials, and then you can use that IAM role that's attached to the Lambda. Guess what was attached to that Lambda? Access to the S3 bucket that store all the other documents that we were processing at the time. Guess what these documents have in them? Lots of people's PII. Not good. Now, being the smart and intelligent product security engineer that I am, I developed a really good defense in depth strategy. I had automated detections in place that I built myself. Whenever a set of IAM credentials was used, outside of the normal, whether that was doing things that it wasn't normally doing, or if it was being invoked from an IP it wasn't normally invoked, or from an environment it wasn't normally invoked, or it was just outside the organization, that's really suspicious. So I had detections written for that. I was able to deal with the problem within the first 15 minutes, shut off the IAM role within 8 hours because I have a very good relationship with that app dev team. The issue was able to be resolved, and we were able to do our forensic analysis from there to look back and see if it was ever a big problem. It wasn't, thank God, but big problem averted because I had a strategy in place to deal with it in case it happened. Conclusion.
Blind SSRFs are extremely nuanced. Hopefully this provides a good foundation for what they are. I will give the next slide because it has our it has your LinkedIn and then the presentation under my GitHub.
You can't hire me anymore.
Do we have any questions?
That guy. Woo!
Do you ever do any threat modeling with the application owners when you set up your Terraform?
Yeah, so I like to do threat modeling as code using like Thragile or OAST Dragon, I think it's called. Any of those types of tools are really good. I will create the initial threat model for products and applications with the app team in hand, and then I actually hand it off to them, and it's literally part of the repo that the project is being built in. So anytime they make changes, they add stuff to it, I go, hey, have you updated the threat model? Because it's in their thing that goes, hey, I need to update this. Other questions? How did I fix the issue, or how did I find? Oh yeah, so the way PDFs, like if you're doing a lot of PDF automation, and I don't blame you if you haven't, PDFs are dumb. Don't work with PDFs. I hate them. A lot of PDF manipulation happens through a number of tools. One of them is ImageMagick. ImageMagick is a really common tool that is like default on like almost every Unix distribution for whatever reason, and it's always a really old version, and you don't realize it's there. Update it. Another thing is like update a tool called GhostScript. GhostScript is a tool that was originally written in PostScript for PDF automation stuff. You know how they solved all of their problems with vulnerabilities due to PostScript? They stopped using PostScript. They just changed everything to C. Also, ImageMagick has a bunch of like additional controls that you can configure that weren't initially configured because we didn't realize they existed, that you can say, hey, open this in a sandbox. This sandbox only has access to temp directory, not Etsy password or any of those other fancy things, or like proc environ, which is where like another place where like IAM credentials might be stored. Any other questions? Cool. Ooh, that guy again.
Do you have any recommendations for people who want to submit blind SSRFs to a bug bounty?
Trust the analyst. No. We have, let's see, blind SSRF. It depends on what method you're using. There is some guesswork, but if you think you have a blind SSRF, just send it in. We'll take a look at it. There's no harm. We won't lower your hacker reputation. We'll try to work with you. Yeah, they're so nuanced. It's hard to say, but there's some you can proof out. The example I showed at the out of band, if you get an internal IP responding to you with an HTTP request to your collaborator, yeah, you got a blind SSRF. If you are more nuanced or you're not sure if it's going through, maybe you're getting inbound but you're not going outbound, go ahead and submit.
One last chance. Any questions? If not, thank you guys so much for coming. Really appreciate it. We're two people in silly hats.